Hello students, today we will be discussing about levels of measurement and application of statistics in psychology. The objectives of this module are to know the meaning of measurement, to understand 4 levels of measurement, to identify and differentiate between continuous and categorical variables, to know the application of statistics in psychology. Meaning of measurement. As psychology is objective, scientific and application-oriented, the concept of measurement plays a very crucial role. Measurement refers to the process of systematically assigning numbers to objects or constructs and their properties. This facilitates the use of mathematics in studying and describing such objects or constructs and their relationships. The application of mathematics makes the findings of psychology more robust. According to Cliff in 1973, scaling or measurement is not simply the assignment of numbers to events according to rule. Rather, meaningful scaling only takes place when several ingredients exist. The first of these is a set of data relations which are at least fairly consistent. A second requirement is the existence of a mathematical model whose variables can be matched with the empirical conditions and the relations among them. These, together with solution procedures, provide a basis for solving numerical values of the variables in the model. And it is these numerical values attached to empirical conditions which are the scales. Young in 1984 stated that measuring produces measurements. According to him, measuring is a process that uses rules to assign numbers to attributes of things or events observed in circumstances assumed by the observer to be quantitative, whereas when assumed to be qualitative, the process is known as scaling. Thus, scaling and measuring both produce measurements by applying rules to assign numbers to observed attributes of things or events. The difference is that scaling derives measurements from qualities, that is, we get scale values, whereas measuring derives measurements from quantities. Measurement is important because it attempts to represent the concept or construct of interest accurately. Measurement is also helpful in the selection of the appropriate method of analysis. But one must be mindful that while measuring a particular concept, construct or phenomenon in psychology, certain error is committed. This type of error is termed as measurement error. Measurement error refers to the degree to which the observed values are not representative of the true values due to certain reasons. So what are these reasons? First, the reason may be attributed to faulty measurement instrument. That is to say that we have selected an inappropriate response scale for the measurement of our interest. Second, error may also be due to mistakes that occurred during the data entry for the analysis. Third, there is a chance of error because of the mistake committed by the respondents or the participants in our study. Therefore, we must be careful while measuring any object, concept, construct or phenomenon in psychology. At the same time, we must be proficient in knowing and identifying the various levels of measurement so that suitable mathematical calculations could be applied in order to analyze and interpret the obtained data. Generally, there are 4 levels of measurement, which are sometimes also known as scales of measurement. These levels of measurement originate from the theory of scale types propounded by a psychologist named Stanley Smith Stevens in 1946. According to Stevens, all measurement in science is conducted using 4 different types of scales, and these are nominal, ordinal, interval, and ratio scales, unifying both qualitative and quantitative dimensions. In psychology, these 4 levels of measurement are having much significance. As you will see, the nominal scale provides a means to categorize entities and is hence a basic measurement scale. The ordinal scale is more informative than a nominal scale by allowing to order entities, but it is still a crude measure. The interval scale is a numeric scale used to arbitrarily measure variables. The most refined measurement is provided by the ratio scale, which identifies the absolute value. We will now consider the different levels of measurement or scales of measurement with examples. Let us first look at the nominal scale. Nominal data are also known as categorical data. With nominal data, the numbers function as a name or a label. Here, the numbers do not have any numeric meaning. The number is assigned as a way to label or to identify subjects or objects. The assigned numbers have no quantitative meaning beyond indicating the presence or absence of the attribute or characteristic under study. The numbers provide only the frequency of occurrences in each class or category of the variable under study. The assigned number represents only the categories or classes without implying any amount of an attribute, characteristic, or variable. For this reason, we can count, but we cannot order the nominal data. Thus, a set of data is said to be nominal if the values or observations belonging to it can be assigned codes in the form of numbers, where the numbers are simply names or labels. Demographic attributes such as gender, occupation, and socioeconomic status are examples of nominal data. In a data set, in order to code the gender of the participants, we may use the number 1 to code male participants, while female participants may be coded with the number 2. While taking occupation, similarly, we may code doctor as 1, lawyer as 2, and pilot as 3, and so on. Instead of 1, 2, 3, we may even use any other digits or numbers to code the nominal or categorical data. In case of gender, we may even reverse the coding such that male participants will now be coded as 2, while female participants are coded with the number 1. Or we may use completely different numbers such as 10 and 11 respectively to represent males and females. What numbers are used as codes is not important because they are only arbitrary labels. The second scale we will look at is the ordinal scale. Ordinal scales indicate the order of the data according to specific criterion or principle. Variables are ordered or ranked generally in relation to the amount of attributes possessed. Every subject or object can be compared with another in terms of a greater than or a lesser than relationship. Numbers assigned are really non-quantitative because they indicate only the relative position in an ordered series. Ordinal level of measurement provides no measure of the actual amount or magnitude in absolute terms. It only provides, as mentioned earlier, the order of the values. Here, the investigator or the researcher knows the order, but not the amount of difference between the values. The ordinal scale assigns a number to each subject or participant to indicate his or her position in comparison with other subjects or participants along certain dimension. Example, in a sporting event, medals are given according to the place obtained. The first place bags gold, while the silver is given to the second place and the third place gets bronze. This ranking provides an indication of who is the best, but not by how much. Or, in the Indian Army, we have ranks assigned to individuals telling us about their position in the organizational hierarchy. An insignia with 2 stars tells us that the person is a lieutenant. 3 stars indicates captain, while an insignia with the national emblem informs us that the person is a major. Ranks obtained in an examination or ranks assigned to preference are also examples of ordinal data. Thus, data are said to be ordinal when an arbitrary numeric scale is used and where the exact numeric quantity of a particular value has no significance beyond its ability to establish a ranking over a set of data. A problem with ordinal measures is that their distributions are rectangular. That is, we have one frequency per number, instead of being normal, unless tied ranks are permitted and they pile up in the middle of the distribution. The third scale we will be looking at is the interval scale. This is the next highest level of measurement precision. The interval data possess constant units of measurement for which differences between any 2 adjacent points on any part of the scale are equal. Interval level of measurement contains an arbitrary 0 point. Generally, 0 means absence of certain property, but here 0 means the presence of that property. Temperature is an example of an interval scale data. 0 degrees Celsius temperature means there is a presence of temperature. Age is another example of interval data. An unborn baby or fetus would be said to be of the age 0 years, but this does not imply the absence of age. Nearly any mathematical operation is possible with interval data, but multiplication and division are not appropriate with interval data. It is not possible to say that any value on an interval scale is a multiple of some other point on the scale. For example, measurement of unit of temperature in Fahrenheit scale, that is, 40 degrees Fahrenheit into 2 will give you 80 degrees Fahrenheit. However, there is no mathematical sense in stating that 80 degrees is twice as hot as 40 degrees. Interval scales are a rarity. In fact, it's difficult to think of examples of interval data. For this reason, the term interval data is sometimes used to describe both interval and ratio data in psychology. The fourth and the final scale we will be looking at is the ratio scale. The ratio data form is the highest level of measurement precision. All mathematical operations can be performed with this type of data. Ratio data possess constant units of measurement for which differences between any two adjacent points on any part of the scale are equal. The data also contain an absolute 0 point. Here, 0 means the absence of a certain property. Ratio data also possess the advantages of all the lower scales we had just considered, that is, the nominal scale, the ordinal scale, and the interval scale. Weight, height, distance, and duration are all examples of ratio scale data. Ratio data can be spoken of in terms of multiples when relating one point on the scale to another. Example, 200 grams is twice as heavy as 100 grams. All mathematical operations are possible with ratio data. Given that there are different scales, the researcher must identify the measurement scale of each variable used in the study so that qualitative data are not incorrectly used as quantitative data or vice versa. The level of measurement is also critical in determining which data analysis techniques are most applicable to the data, with consideration made for both independent and dependent variables. Continuous and categorical variables. One of the essential properties of data or variables is their dimension, that is, the set of values that they can assume. There are several dimensions of data. One of the dimensions represents classes of data, and these are continuous and categorical. Let us first look at the continuous variable. If a variable can take on any value between two specified values, it is called a continuous variable. The relative magnitude of the values is significant. For instance, a value of 10 indicates twice the amount of 5. The age of a person is an example of continuous variable. Suppose a researcher requires that all the participants in his or her study must be between 15 and 30 years of age. Here, a participant's age could take on any value between 15 years and 30 years. For example, the participant may be 16 and a half years or 28 and a quarter years. Likewise, height, weight, income, blood pressure, and body temperature represent continuous variables. Thus, continuous variables can assume an infinite number of values. Let us now consider the categorical variables. Categorical variables are also known as discrete variables. A category represents a set of people or objects that have a common characteristic. Categorical data consist of counts of observations falling into specified classes. We represent categorical data in the form of a contingency table or cross-tabulation. A categorical or discrete variable cannot take on any value between two specified values. For example, when we toss a coin 5 times and count the number of heads, the number of heads could be any integer value between 0 and 5. However, we cannot get 2.5 or 3.25 heads. Therefore, the number of heads represents a discrete or a categorical variable. Other examples of categorical or discrete variables include an individual's gender, that is, male or female. Occupation, such as teacher, doctor, or engineer. Marital status, such as unmarried, married, divorced, or widowed. And socioeconomic status, which is high, medium, and low. A categorical variable has values that function as labels or names rather than as numbers. As Dodge in 2008 pointed out, we can distinguish between various types of categorical data such as binary, unordered multi-categorical, ordered multi-categorical, and whole numbers. Binary category involves characterizing the presence or absence of a property, for instance, yes or no type of answers. Unordered multi-categorical refers to nominal data such as male and female. Ordered multi-categorical includes ordinal data such as primary class, secondary class, and higher secondary class. Note that we are arranging the classes in a particular order, that is, in terms of their progression from primary class to higher secondary class. And for whole numbers, you may consider the example of categorizing a family basing on the number of family members, such as large family and small family. We have just differentiated between discrete and continuous variables. However, the distinction between these two is rather vague because many quantities can be represented as both discrete and continuous. Variables that are basically continuous can also be presented as categorical or discrete variables. The example of age we had considered earlier that may be expressed as a continuous variable such as 16.5 years and 28.25 years can also be grouped into two classes and presented as categorical data such as adolescence and adulthood. When a person rates the beauty of others by using a 4-point scale, it is considered a continuous variable. The same data may be treated as discrete variable when it is represented as 4 categories such as most beautiful, very beautiful, beautiful, and ugly. Application of statistics in psychology. Statistics is derived from the Latin word status, meaning state. Thus, the term statistics is used to indicate a set of available data about a given phenomenon. Example, employment statistics or health statistics. In a more advanced sense, statistics is considered as a separate discipline. Thus, statistics is a branch of mathematics devoted to the collection, compilation, organization, display, and interpretation of numerical data. Psychology is more concerned with applied statistics rather than with the mathematical development of statistics. Strickland in 2001 explained very lucidly the importance of statistics in psychology. Let us consider some of these major applications of applied statistics in the field of psychology. First, psychologists depend heavily on statistics to help assess the meaning of the measurements they make by means of administering psychological tools such as tests, scales, questionnaires, inventories, and so on. Second, psychologists use statistics to construct and develop psychological tools. In psychological testing, the psychologist may interpret the test results in light of norms or the typical results provided from previous testing basing upon the statistical analysis. Third, statistics is used in psychological research for describing the structure and properties of the group under study. For this, psychologists use descriptive statistics, which simply gives a general picture of the scores in a given group of individuals or the research sample. That is, the measures of central tendency, which are mean, median, and mode, and the measures of variability, which are standard deviation and variance. A fourth application is that statistics is used in psychological research for drawing inferences or conclusions about the population using the data obtained from the research or from the sample. For this, psychologists use inferential statistics such as t-test, analysis of variance or the f-test, and correlation coefficient. The t-test and ANOVA or the analysis of variance help the psychologist to assess whether the differences in averages across groups are due to the effects of an independent variable. The correlation coefficient, on the other hand, is used to describe the strength of the relationship between two variables. There are a large number of inferential statistics used by psychologists. Statistics is also essential for determining the size of sample or the number of individuals in groups required for the research. Establishment of techniques of sampling is based upon the statistical formula, which determines the representativeness of the sample for the population. Sixth, statistics help psychologists assess the outcome and effectiveness of any psychological experiment and intervention. Without statistics, comparison between the test performance before the intervention and after the intervention may be difficult, and further, the interpretation may be loaded with subjective bias. Finally, statistics also make us aware of the prevalence rate of a disease and its prognosis. Statistics help us understand a particular phenomenon to be researched upon. Thus, applied statistics help us develop and monitor proper intervention programs. Therefore, statistics are powerful and useful in research. However, it is also important to understand that statistical procedure is only a middle step in the investigation of a research question. If all the extraneous variables are not controlled carefully, we may make a correct statistical conclusion, but an incorrect or a false research conclusion. We should also remember that a statistical conclusion is always about a probability. Minium, King and Baer in 1993 opined that the statistical procedure used to analyze data cannot tell whether the numbers used are the results of empirical observations or of someone's imagination. Considering all these, we must be careful while applying statistics in psychology in order to find out answers to our research questions. The increasing popularity of and demand for qualitative research designs and methods reduce the application of statistics in psychology in contemporary research. However, applied statistics creates a separate niche for psychological research. Measurement and statistics represent fundamentally different approaches to analysis. Measurement is concerned with examining the extent to which data fit a model, whereas statistics is concerned with building a model to fit the data. But the concepts of measurement and statistics do have a symbiotic relationship. When fundamental measurement is achieved, the researcher is able to develop a set of variables that meets the strict assumptions of his or her preferred theoretical model. When this kind of pure measurement is achieved, the researcher is then in a position to use various statistical techniques to analyze the data and to contribute valid, replicable findings to the research community. Though there are so many questions raised about the relevance of statistics in psychology, yet if applied with correct sense and precautions in the direction of achieving the answers to the research questions, statistics increases the scientific vigor of the study or research.